Okay, today we're going to be doing leetcode 1346. Check if n and its double exist. So you're given an array called array of integers and check if there exists two integers n and m such that n is the double of m, right? So you're trying to find whether there are two integers where n is the double of m, right? So more formally, check if there exists two indices I and j such that I does not equal to j. So in other words, these two numbers have to be at different indices, right? And they are within the range, and the value at I is twice the value at j. So this can be a bit misleading, like trying to focus on the indices, because at the end of the day, returning true. But anyways, we're going to do the brute force first, which is you just iterate through every possibility, right? So for I in range, length of array, then for j in range, length of array, we check for the condition asked, right? So if I does not equal to j, right, because there are those cases where, for example, the first time we're iterating here, the first time we come down here, I and j will be the same. So if I does not equal to j and array at I is equivalent to 2 times array at j, then we simply return true. We have found it. Otherwise, when we come through all this, we return false. Voila, it works. But this takes quadratic time, right? Of n squared, right? Because of these double for loops. So a way to do this better, some people may do like a binary search here so that it's n log n, but then you still have to first sort it, right? Which takes n log n time. So we can do this in O n time by iterating through the array and having a set, not a hash map, because a hash map you may have duplicated values where I is equal to j, what they were trying to discourage here, right? So we use a hash set, right? So we iterate through nums and we check if twice the value that we're seeing exists in the hash set or half the value exists in the hash set. Because if that is true, then we have found a value of either I or j, right? For example, if it is 10, we'll check and we'll realize that, oh, this 10 is in the hash set. So let's do it here. So we create a set slash hash set, which has O of 1 lookup time. So we'll call it our store is equal to set. Then we iterate through the array and checking for condition. So for num in array, we check if num exists, if num condition is satisfied and that value exists in the set. So if num by 2 in store or num times 0.5, right, which is the same as divided by 2, right? But the good thing about doing it's better you do 0.5, because if you do divided by 2, it may not work. Then we simply return true, right? So since this is a hash set, we don't have to find out a way to check if num1 is if this value is at a different index or whatever. Otherwise, we simply add num to the set. So store.add num. And then when we come here, we simply return true. Let's run that. Oh, hold on a second. Oh, on in store. Sorry, forgot to add that. In store. If num times 2 in store or in store, we simply add. That's interesting. I didn't have that issue before. Sorry. I didn't have that issue before. What could be the problem? See, it worked here. Right? For num in, okay, let's just rewrite it one more time. Because for num in array, if num times 2 in store or in store, return true. Otherwise, yeah, this should have been easy, right? So store is equal to set, and then for num in array, if num times 2 in store or num times 0.5 in store, then we return true. Otherwise, store.add num. Then we return false. This should work. Yeah. So I don't know what had happened before. So let's try it with a half here and see what happens. Because this was giving me issues, right? It doesn't work. It has to be times 0.5. That's when it will work. So yeah, this solution is O of n time and O of n space. So that's it, and thank you.